Today's lesson is about parallel lines and transversals, section 3.4. What we need to understand what's transversal. If you have two parallel lines and then you have the third line that is crossing them, that line is called transversal. Now, the two lines don't have to be parallel to be crossed by the third line, which is transversal. But what is important for us when we have two parallel lines crossed by the transversal, then there are angles that are equal to each other, and we can use that to solve problems. So here we are. Let's say, look at these two parallel lines. Here is the transversal crossing it, and there are 8 angles that are formed there. Now, among those angles, you have some angles that are called corresponding angles. And corresponding angles are two angles that occupy corresponding positions, which means they have a relative position, the same relative position to the transversal. So what am I talking about here? Look at angle 1 and 5. They both are to the left of the transversal, above the parallel lines. They have corresponding position. Angle 3 and 7, they are both to the left of the transversal, below the parallel lines. They are corresponding. Angles 2 and 6, they are to the right of the transversal, above the parallel lines. And then 4 and 8 are to the right of transversal, below the parallel lines. Now, why are they important? It's important that each pair of corresponding angles have the same size. So angle 1 and 5 have the same size. Angle 3 and 7 have the same size. 2 and 6, and then 4 and 8. Another set that we need to understand is the relation between vertical angles. So what are the vertical angles? Two angles that share a common vertex. If we have two lines that are crossing at the point, angles that are touching each other just at the vertex, they are called vertical angles. And these two are vertical angles. And what's here is when we have a transversal and two parallel lines, what are the vertical angles? So 1 and 4 are vertical, 2 and 3 are vertical, 6 and 7 are vertical, and 5 and 8 are vertical. And what's true about them is that each pair of vertical angles have the same size. And we can use these facts to solve the problem. So here we are. Let's say we have this. We have these two parallel lines crossed by that transversal. We have 8 angles formed, and angle 1 is 130 degrees. So how can we find the rest of the angles? First of all, angle 2 we can find based on the fact that angle 1 and angle 2 together, they are next to each other. We call them adjacent angles actually. They form a straight line, which means they are together 180 degrees. So 180 minus 130 will give me angle 50. That's the only one I need to find out. The rest of them, I just need to use my relation between those angles, whether they're corresponding or vertical, and figure them out. So angle 3 is across from angle 2. They are vertical to each other, has to be the same. Angle 4 has to be the same as angle 1 because they are vertical from each other. Now angle 5. Angle 5 and angle 1 have a relative position to the transversal the same, so they're corresponding. They have to be the same. And then angle 6 has to be the same as angle 2 because they are corresponding, or I can also find it by the fact that 5 and 6 form a straight line. They're equal to 168 degrees. And then angle 7 has to be the same as 6 because they are vertical to each other, and angle 8 has to be the same as angle 5 because they are vertical to each other. Now, another thing that might be interesting to us is the fact that, let's say, parallelogram. If we have a parallelogram, opposite angles in every parallelogram are equal to each other. They are congruent. So if that one is 120, the opposite is 120. If this is 60, the opposite has to be 60. So, and the total sum of them is for sure 360 degrees. If we extend all lines, all sides of the parallelograms, we notice we have actually two sets of parallel sides that are we can actually use to figure out all missing answers. So missing angle, sorry. So if this angle is 60, that one has to be 120, because first of all, it's corresponding to that one, and also they add up to 180, form the straight line. Then this small angle has to be 60, that one has to be 120. That applies that absolutely every angle around has to be either 120 or 60. So here we are, small angle 60, big angle 120, small angle 60. Here, small angle 60, big 120, small 60. 120, 60, and 120. So now, let's start our notes. So now, in your note packet, if you look at the vocabulary, how do you know that the lines are perpendicular? That's another vocabulary word. They cross at 90-degree angle exactly. Parallel lines, we know, never intersect, so these two are parallel lines. Adjacent angles are two angles that share common vertex. They are next to each other, and that would be important for us. Two angles that form a straight line, they are adjacent actually. They touch each other. Vertical angles, we talked about that. Opposite, they just touch each other at the vertex. 1 and 3 are vertical. And then transversal and parallel lines, we already talked about those. All big angles here have to be the same, and all small angles have to be the same. So now we use all of that to solve the problem. We have a drawing. We need to find all missing angles in this parallelogram. First of all, we can extend all of those lines to see that we have two sets of parallel lines. And second thing we can use is that opposite angles in a parallelogram are congruent. They have the same size. So to find angle 1, we know with angle 122 it forms straight line which is 180 degrees. So we simply subtract 122 from 180. We have that angle 1 is 58. Angle 2 has to be 122 because first of all, if this angle is 122, corresponding angle here has to be 122, and then 2 is vertical to it, so it has to be 122. Angle 3 is within this parallelogram. It's opposite from 1, so it has to be 58. Angle 4 corresponds to angle 122. They take the same position, so that one has to be 122. Angle 5 is vertical from 3, so it has to be the same as 3, it's small angle. And then angle 6 corresponds to 5, has to be 58, and it corresponds to 1 as well. So here, if we need to find the measures of all angles, and this is not in your notes, this is kind of just to look at it, what can we do? Here we are, vertical from that has to be 120. 60 has to be the small one. Vertical from that has to be 60 as well. Now, if we look opposite there, this angle here corresponds to this one, so it has to be 60. Vertical from it has to be 60 as well. This angle has to be 40 because it's vertical to that angle up there. Now what we can find this one here, that's 180 minus 40 plus 60. These two angles, because all of them together form 180, which is 80. And then from that point, this one is vertical, that's 80. That's corresponding to this one has to be 80. That has to be 80. And then this is 100 because these two form 180. That one is vertical, has to be 80.